Welcome to this explainer. Today, we're looking at an absolute marvel of mechanical design. Seriously, we're going to completely reverse engineer this awe-inspiring single-take transformation of a clockwork toy. We're talking about a seamless, faceted gemstone that physically unfolds entirely on its own into a fully articulated, living, breathing mechanical dragon. If you're fascinated by the engineering behind toy metamorphosis, you are absolutely going to love this.
Okay, let's dive into this, because when you first see this happen, your brain immediately screams magic, right? Or, maybe computer graphics. But the reality of the physical engineering here is actually way more impressive than any magic trick. How does a compact, solid shape suddenly sprout wings, legs, a head, and a tail without adding a single piece of extra matter? It's wild.
So, the crucial point is summed up perfectly in this quote from our source material. No new parts appear, and the completed dragon remains fully consistent with the original toy's size and engineering. That means absolutely no camera tricks and no CGI. Every single gear, spring, and polished brass claw you see at the end of the transformation occupies real volume and physical space inside that tiny starting crystal. Just think about the stark contrast between these two states, because it really establishes the massive physical constraints the engineers had to overcome. On one hand, you have the original state, this faceted crystal shell, perfectly seamless, shaped just like a pristine gemstone. And on the other, the transformed state, a complex creature with exposed gears turning, expanded layered wings, and 4 articulated limbs. Getting from point A to point B without any extra pieces is a literal masterclass in spatial problem solving. Let's walk through this uninterrupted chronological sequence, which is captured entirely in a first-person perspective. At 0 seconds, a right thumb rotates a clearly visible brass key switch until it locks with this highly satisfying metallic click. The toy is gently placed on an oak tabletop. By 3 seconds, the transformation is underway as the core physically rises. Around 8 seconds in, the head and legs deploy in a complete flurry of mechanical precision. And by 12 seconds, the wings and tail unfold to complete the silhouette. It is just a continuous, rhythmic unfolding of metal and glass. Section 1. Unlocking the clockwork core. Let's move to and see how this builds. First, that brass key switch is rotated. This mechanical input physically retracts miniature locking pins hidden inside. With those pins out of the way, the faceted crystal shell suddenly separates along these incredibly precise, machine-crafted seams. Finally, triangular brass-framed crystal panels rotate outward on concealed hinges. It's a sequence of perfectly timed physical triggers. And as those panels open, they reveal a staggeringly dense network. We're talking interlocking gears, rotating flywheels, precisely milled cams, tension springs, and polished drive shafts. This is the mechanical heart of the toy, and as it begins to operate, the internal frame actually rises slightly, pushed up through telescoping structural supports. It manages to maintain the toy's original physical volume while completely changing its internal geometry. It's incredible. The absolute secret to how the dragon achieves this lies in this concept: nested mechanical layers. This basically means components are folded incredibly compactly within each other, kind of like a Russian nesting doll, ready to deploy outward. By utilizing nested layers, the engineers can create incredibly complex structures, like a long tail or wide wings, from a very small volume, without relying on impossible, logic-defying expansion. Section 2. Deploying snout, jaws, claws. Now, what's really interesting about this slide is the engineering driving the front section. Telescoping rails. Think of a classic collapsible spyglass. Tubular or track-based mechanisms slide out from one another to drastically extend their length. The dragon's head actually emerges from nested mechanical layers, and a finely crafted mechanical snout extends smoothly outward, riding on these tiny telescoping rails. As that snout extends, the face literally builds itself. Segmented facial plates rotate mechanically into position. Then, polished glass eyes actually slide forward, taking their place behind protective brass rings. To finish off the head, the lower jaw unfolds on precision hinges and opens and closes once, driven perfectly by synchronized gear movement. The timing is immaculate. Down below, 4 articulated legs deploy from completely hidden compartments beneath the body. To achieve a stable stance, the legs follow a precise 4-step process. First, each leg telescopes outward section by section. Second, they rotate through multiple joints to find the exact right angle. Third, they lock securely beneath the chassis. And fourth, tiny brass claws unfold from nested metal layers already contained within each foot. Section 3.
Engineering the expanding wings.
Just look at this deployment sequence. First, the solid-side crystal panels divide into multiple feather-like mechanical segments. Then they extend outward using a highly coordinated system of sliding rails. They rotate outward on hinges, and finally, folding support ribs snap into place to give the wings structure. Every single wing panel originates from the original gemstone shell. They've engineered broad, elegant layered wings entirely from existing mass. There's no cheating here.
Section 4. The final segmented masterpiece. Moving to the back, the rear housing literally separates into progressively smaller sections. Each tail segment unfolds from within the previous one, utilizing precision guide rails and rotating joints. It's this beautiful cascade of telescoping metal that curls naturally behind the dragon, finishing with a final decorative tail tip that rotates into alignment and locks securely with a tiny, audible click.
1. That is the number of camera takes required to capture this entire metamorphosis. A single, uninterrupted long take. No camera jumps, no clever edits. The camera remains perfectly steady, focused on the oak tabletop, allowing you to witness the physical reality of the engineering unfolding in real time.
Section 5. The kinetic climax.
And this brilliantly illustrates the true genius of the toy's core. Look at all these continuous, synchronized movements happening simultaneously. The layered wings slowly unfold to full display, then fold back halfway. The segmented tail sways gracefully side to side, the head tilts curiously, the glass eyes shimmering under the warm light. Those tiny brass claws make subtle balancing adjustments. And, right behind transparent crystal windows, the exposed clockwork gears continue turning, driven by cams, springs, and spinning flywheels, keeping the dragon buzzing with living kinetic energy.
As our source highlights, this steady documentation emphasizes cinematic realism, satisfying mechanical motion, premium clockwork craftsmanship. Now, this matters because it proves what is actually possible with tactile craftsmanship. In an age where almost anything can be simulated on a screen, seeing a physical object execute this level of macro detail, photorealistic materials, and physically believable engineering is profoundly satisfying. It's a masterclass in spatial problem-solving that you can literally touch. Which leaves us with this final thought. In an era completely dominated by digital illusions and CGI magic, doesn't physical, photorealistic engineering like this represent the true pinnacle of design? The enduring magic of real-world mechanics, where every gear has a purpose and every fold is dictated by the laws of physics, remains utterly captivating. It makes you wonder what else is possible when we push the boundaries of mechanical engineering. Thank you for joining me on this explainer, and I hope you never look at a clockwork toy the same way again.